Hello everyone. Today I am going to explain a project in communication domain, which is a novel low complexity based PAPR reduction in OFDM systems. First of all, our main aim of the project is to reduce call drops in 4G and 5G technologies. For that, we choose OFDM, which has the property of multi-carrier modulation and high data speed rate. So, in this we are using the massive MIMO, which is multi-input and multi-output. For using this MIMO, we have to connect so many number of users with a large bandwidth and containing more number of data. In this, the major drawback is PAPR. So for reducing the PAPR, there are so many techniques like clipping, filtering, zero forcing, etc. And the existing method is ENGAM. But in our proposed method is RCTF. In this, the contents are abstract, introduction, existing method, drawbacks, proposed method, advantages, applications, conclusion, future scope, and references. Abstract. In this, we consider the problem of peak to average power ratio, which contains massive multiple input and multiple output and downlink system. Here we contain two systems, which is uplink system and downlink system. Downlink system means satellite to ground communication, and uplink system means ground to satellite communication. Here the existing method is ENGAM, which means expectation and maximization. In this, we are estimating the hyperparameters, and this based on the prior model. And another technique is GAM, which is generalized approximate message passing. By combining these two, we are reducing the PAPR up to 8 dB. In this, the complexity is more. So by reducing that complexity, we are introducing a technique that is RCTF, and by using this technique, we reduce the PAPR up to 6.5 dB and also calculate the bit error rate. Introduction. OFDM is a powerful multi-carrier modulation technique, and it contains a subcarriers which is in broadband wireless communication. OFDM is combined of low data rate carriers to construct in high data transmission in modern communication. It contains the wave means orthogonality, which means 90 degrees phase shift. Here, high PAPR is one of the major drawbacks in OFDM. So, here we are using massive MIMO, which is in antenna technologies for wireless communication in multiple antennas are used at both base stations and mobile stations. This is the block diagram of OFDM. First of all, we are encoding the signals. Here we are using the modulation technique, that is QAM. For any information for transmitting, we have to use in the modulation, which means we have to add the subcarriers for the message signals for the transmission of data. In this, we are using QAM and converting this data from serial to parallel conversion. And for any channel receiving, we have to convert the signal from frequency domain to time domain. So for that, we are using the IFFT. In this, for transferring more number of signals, the PAPR problem arises in this IFFT block. So in this, we get the PAPR problem, which means peak to average power ratio. By removing that peak powers, we are using the cyclic prefix. This cyclic prefix is used to make the signals flat and converting the signals from parallel to serial and from digital to analog conversion. After that, we are converting the channels from receiver, and we are converting the signals from analog to digital converter and from serial to parallel. And we are removing the cyclic prefix. Why? Because here cyclic prefix occupies some bandwidth, but we have to remove that unwanted bandwidths. So we are removing the cyclic prefix and converting the signals from time domain to frequency domain. For that, we are using the FFT and converting the signals from serial to parallel and decoding the signals. So this is the major OFDM block diagram. And next, MIMO. In 1998, Bell Laboratories introduced these MIMO systems. Here we are using two types of antennas, that is direct and reflected antennas. PAPR means peak to average power ratio. It is the ratio of maximum of the signal to the average power of the signal. In this, some of n sinusoidal signals are combined and creates large peaks. According to IEEE 802.11n, the PAPR range is up to 4 dB. This is the existing method, and that method is EM-GAM technique. Here we are using the likelihood function for best method of use signals in signal processing. EM is the iterative method and it estimates the hyperparameters along with their prior model. Here we are using two types of techniques, that E-step and M-step. The disadvantage of the technique is it contains the hyperparameters associated with the prior model, and EM plus GAM, which leads to complexity, it increases. In this in-band distortion, compared to in-band distortion, outband is more critical and it is severely interference in the radio communications. So for reducing the drawbacks, we are introducing a technique that is RCTF, which means repetitive compounding and transform filtering and technique. In this we are using the PAPR reduction and also improve the OBI. OBI means outband interference. This is the RCTF block diagram. In this first we are converting the signals by using IFFT. Here we are using the compounding transform technique for checking the matrix which is symmetrical or not. If the matrix is symmetrical, we are transferring the data directly to the receiver. If the matrix is unsymmetrical, we are again filtering the signals and removing the noise and cancelling the PAPR and converting the signals from transmitter to receiver. In this, the PAPR can be reduced in the transmitter only. So in the receiver, we are inserting cyclic prefix and amplifying the signals by using high power amplification. In this we are using a feedback loop to check where the data is missing. In this, at the transmitter side only we are reducing the PAPR. So at the receiver side we have to receive the data without any loss. So here cyclic prefix is used to make the signals flat. This is the result of our project. In this is the version of OFDM signal and this is the block by block execution. So finally we have to reduce the PAPR up to 6.5 dB. We are also calculated the bit error rate along with the PAPR. Here we also calculated the bit error rate in two channels, that is AWGN channel and Raytheon fading channel. This is the output of AWGN channel. Here the bit error rate range should be 10 power 0 to 10 power minus 4. If this range will be allocated, the system should be efficiently work out. So we have to reduce the bit error rate in between 10 power 0 to 10 power minus 4. This is the Raytheon fading channel. In this also we are reducing the bit error rate up to 10 power 0 to 10 power minus 4. Advantages. So we reduce the PAPR up to 6.5 dB. So it means less PAPR loss. Good performance of BR and SCR. Here MUIs is reduced and compared to previous method, complexity is also reduced. Outband interference is also reduced. Applications. Generally OFDM is used in 4Gen 5G technologies. So it is applicable for wireless communication. So it is used in mobile communication, digital audio broadcasting, digital video broadcasting, wireless technology and broadband wireless access systems. Conclusion. We consider the problem of PAPR and also we reduce the multi-user interference by based on a massive multiple input and multiple input downlink system. The proposed method is reduced the complexity as compared to the previous model. It uses less number of iterations for reducing the PAPR. Future scope of the project. Most currently available techniques PAPR reductions have more number of computational complexity and the techniques takes more number of iterations. So by using the iterations, the output for the project is taking more time. So by reducing the time and we also reduce that complexity by using the RCTF technique. The future scope of the project is to reduce the PAPR up to 4 dB as per the IEEE 802.11n standard. These are the references. Thank you. We are using the MATLAB for the simulation and MATLAB is eco-friendly and we have to reduce the PAPR by using this MATLAB software.
We had a written code for this to reduce the PAPR.
Now we are running the project.
Now we have to enter input users. The users should be greater than the length of the channel. These are the outputs.
This is the PAPR output, and we register the PAPR up to 6.5 dB. This is the bit error rate output. It is in AWGN channel.